A structure is a collection of related elements, and sometimes they could be of the same data type. Sometimes they could be of different data types. So in some textbooks, these elements are referred to as fields or member variables, right? Or it could be properties, right? Or it could be attributes. But whatever the case is, just think of this entire structure holding various different elements at runtime. And there is a name to this structure. And in fact, we can declare this structure by creating an instance of it at runtime. You might have heard class, right? In object-oriented programming, such as C++, a class is a blueprint for creating objects. So you can think of this structure, which is long for struct, right? Struct is a keyword in C as something that is similar to a class, right? Concept in C++ or Java, right? Or Python. But there's some differences between struct and classes. But in this video, we're going to talk about structures declaration, how we initialize various different fields or elements, how we access, right, these elements inside a structure, how we operate these various different structures, how we're passing them, right, into, for example, a function, right, and various different types of structures. Sometimes we may have an array of structures, for example, inside another array. So we'll explore these various different topics in this video. Here, when we said a structure is a collection of elements, yes, you can have these things being your elements. For example, in this fraction structure, right? This fraction is the name of the structure, and then you can have two fields in it. The first one is the numerator, and the second one is the denominator. So this could be a flow, right? And this one can also be the flow. In the second one, you have this student structure. The name of the structure is called student. The very first ID is an integer. Name could be a C string, right? So this would be a char star. Grade point here again could be an integer. So as you can see, a structure is a collection of various different elements of different types. So you can think of a struct, right, as a collection of multiple fields. So in this case, we have this field list, right? In the first one being a C string ID, second one being C string name, third one being integer grade points. And the name of this struct, right, is student, right? Is student. And you can think of this struct as in, this entire block of memory that holds these informations at runtime. So the format is this, right? You have a tag name, right, or a name that identifies what this struct or memory object is, right? In OOP term, we call everything object. And of course, there is no concept of class when we're talking about struct, because C is not object oriented, right? So there are no objects. So inside this struct, let's say this struct takes 24 bytes, right? Right. This is just an example, right? And the name of the struct is called student, and then you have this fields list, right? So that's kind of the format here, and we always need to enclose, right, our struct, right, with a semicolon, right? This completes the declaration of a structure. The second way of declaring a structure is using typedef, right, struct. So we went over what typedef is. It's a type definition. So you're creating a type, and this is user-defined type of struct, and the tag, right, in this case, or the name of the struct, in this case, was type. So that would be students here. And the same thing here, you can have fields list. And remember, at the end, we need to enclose this entire typedef with a semicolon. The difference really between this typedef struct versus the other struct that we just saw is that this one comes with a typedef keywords. And the other thing is this immediately allows a developer to identify the name of the type. And in fact, there could be multiple instances of this. Let's say this is type, and then you can have X, Y, Z. You can also define another one, right? A comma here, and then A, B, C, right? Whatever this is. So you can actually create multiple, this is what we call instances, right, of this struct that contains this list of fields. we will illustrate this with more examples. After a structure has been declared, we can declare variables using it. So let's see the various. This is variation number 1, variation number 2. They're the same essentially. Using the very first one, we create a structure called student. So the tag name is student, and this is a field list right here. And because this student itself is of type student, we have to ensure that we have the struct student. Otherwise, no one's going to know what this student is, right? This is the entire database. So you have to treat this as almost like a type, a data type. This is the struct student data type, and then you declare an instance of it. So it's almost like writing integer I, right? Where integer is a type, I is a variable, right? So in this case, a student here is a var, is a variable. Okay, so this is one method, and the other method is using type def. Now, if you type define, a structure, you give this type a name, right? Just like integer, just like float, right? Just like, char, just like Boolean, right? In C99 forward, you can have Boolean as well in C. These are native types, but you can define your user type. This is your user defined type called student. And once you type def this, you can treat it just like any other data type, and you can create an instance of it or a variable instance of this student at runtime. So these are the two ways of writing it. I prefer the second one a lot more than the first one because it keeps the code simple, right? Just by looking at this, I can immediately see that this a student variable is of type student. However, you can also go with a more verbose way of expressing essentially the same thing by using a structure using a different format.